Hi everyone, this is your math guru. In this challenge question, I'm going to show you how to find or prove that the area of the shaded region is equal to the area of circle E. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. We have the question shown. Let's assume the distance from A to B is x. So I'm going to state that. So AB equals to x. The middle of the circle has been given as O. So what that means is, if the distance AB, which is also the diameter, that's the distance from one edge of the circle passing through the middle to the other side, is x, the radius for the big circle will be half of the diameter. So we have AO is equal to OB, which is equal to x over 2. The reason being the radii of the circle. If you look at the circle E as shown, what it means is if AO is x over 2, then half of that will be the radius, because AO will be the diameter of the circle E. So therefore, we have area of circle E equals, the formula for finding the area of a circle is pi radius squared. AO is the diameter, so therefore the radius R equals to half of AO. That is equal to half of the AO is x over 2. So therefore the radius R equals x over 4. If I go back to putting that in the formula for the area, that's pi r squared, I will have area of circle E. So I have area of circle E equals pi radius squared. So I'm going to leave my pi as it is. The radius now is x over 4. So times x over 4 all squared. That's equal to pi x squared. 4 squared is 16. What I've done is, applying the exponential law, we state that if I have a over b all to the power of c is the same as a to the power of c over b to the power of c. So if I have x over 4 all squared is the same as x squared over 4 squared, which is x squared over 16. So we've been able to find the area of circle E to be pi x squared over 16. The question says we should prove that the area of the shaded region is equal to the area of circle E. We've been able to find the area of circle E, so the next step will be to find the area of the shaded region. Area of shaded region will be equal to area of the big semicircle minus the area of the small semicircle. So I'm going to add next to that. And what I mean is, if you look at the diagram, if this is my diameter, as stated earlier, the diameter splitted the circle into 2 equal halves. So if I can find the area of the big semicircle as highlighted, then I'm going to find the area of the 2 semicircles and subtract from the big circle. That will give me the area of the shaded region, which is in black. So if I go back to my question, I have area of big semicircle. I have that as pi r squared. I'm going to use my capital R for my radius because it's a semicircle. I'll divide that by 2 minus the area of the 2 semicircles. So I have the first one, that's 2 times pi. I'm going to use my small r over 2 as the formula. So simplifying, we already found the area of the big semicircle to be x over 2. So I'm going to slot that in. I have pi in bracket x over 2 all squared, that's the radius, all divided by 2 minus, if I simplify here, 2 in 2, that's 1, so I only need pi r squared, and that will be pi times the radius for the small semicircle is x over 4, so I have that as x over 4 all squared. Simplifying, I have pi times x squared over 2 times 2, that's 4, times 1 over 2, that's the 2 at the bottom, minus pi x squared over 16. If I simplify further, I have that as pi x squared over 8 minus pi x squared over 16. Because the denominators are different, the LCD will be 16, so therefore I need to make the left hand fraction have a denominator of 16. So I'll multiply both the numerator and the denominator by 2. What I will have will be 2 pi x squared over 16 minus pi x squared over 16. And now that the denominators are the same, the area of the shaded region will be equal to 2 pi x squared minus pi x squared divided by 16. Therefore, area of shaded region will be equal to 2 pi x squared minus pi x squared, that's pi x squared over 16. I'm going to highlight that. So note that the question says show that the area of the shaded region is equal to the area of the circle E. So if I go back to the area of circle E, I have that as area of circle E equals pi x squared over 16. And likewise, if I go back to the area of the shaded region, I have that as pi x squared over 16. So I've been able to prove that both areas are the same. Thanks for watching. Bye.